Solving equations and inequalities containing e. All right, so I'm going to convert between exponential and logarithmic forms. We kind of did a little bit of that in our preview, right? Okay, so if logarithms are exponents, then I'm going to talk about x, because that's my exponent. X equals, well, we're going to go real slow. Log base what? E to the 6. But we just learned a different way to write that. How else could I write this? Ln natural log 6. Make sense? You put that in a calculator and you get an answer. What if I was given this? Natural log x is about, what does about mean? Approximately. Approximately. As close as we can get on a calculator, right? Okay, so how could I rewrite this? Log base e to the x is approximately 0.5352. Okay, how would I put that in exponential form? X equals e to the 0.5352. Good. Okay. Composition functions of inverses. Okay, so can anybody tell me what this would equal? What if I changed it to this? Log base what? E to the what do we do here? Log ln x is the same thing as log e to the x, right? So log e to the what? E to the x. I didn't. Right? Doesn't ln just mean log e? Okay, so what if I had this? You guys know this? Log 5 to the 5 to the 2. What's that? 2. So what's this? If I don't know what this is, right, then it's 5 to the exponent equals, that's how we get 2? See it? So what is this one? E, watch. Mrs. Watkins put the boxes in there last period, and I really, really liked that. E, right, the base to the exponent equals e to the x, so that. So what's this one? Maybe change it. E to the, change ln, put it in logarithmic form. Log e x. What does that equal? Remember these were special, yes, x. Just if it was like this, guys, 5 log base 5x. Remember that? It's the same thing. How you guys doing? Okay, let's start playing with them, and then light bulbs should start coming on. Do you think things that you just automatically see, you just go, oh yeah? It doesn't normally happen that way, right? You got to exercise it, you got to work it, right? Okay. If I were to go and try and run 5 miles right now without taking a break, what do you think would happen? Yeah, I would be very, very tired, right? Right? But my body would get a little bit used to it if I just kept doing it. So let's go work out. Okay. All right. Solve each equation. Okay, pencils down. Let me do this one for you. Okay? Treat it just like exponents. Same rules as logarithms. Okay, so what could you do? We could subtract 2 from both sides. Then I would get 3e to the x equals 2. Yeah, let's make it simple. Let's make it as simple as possible before we turn this into logarithmic form, okay? So I could divide, let's change my color. I could divide by 3. Oh, is she forcing me to give her credit? It's okay, I don't blame her. Okay, so now I have e to the x equals 2/3. Okay, now what? Do you know e to the what makes 2/3? We don't know, right? So what could we use? We could use log e. Okay, I'm gonna use log e, and then we're gonna try and transition to just using natural log, which is ln. Yeah. Okay, so I would say log. Or right, let's do exponent. My exponent is what? Logarithms are exponents, so x equals log. What's my base? E to the 2/3. Let's change it. X equals, what is log e? ln. We'll just make it like this. ln 2/3. Put it in a calculator. Did I just hear you guys go, oh? No? What'd you get? I have negative 0.4055. You got it? It is, isn't it?
Yeah.
Okay. I'm going to say let's go through them and then come back and practice. How's that sound? That sounds great, Mrs. Muller. Let's do that. Are you guys finished?
I'd love to do that, Ms. Muller.
Let's copy that down. Okay, let's move on and come back if we have time. So, pencils down. Solve each equation round to the nearest 10,000. Okay, so I have natural log 3x equals 7. Can you put natural log 3x into your calculator? No. So what strategy could I use?
Convert to logarithmic form.
Okay.
You left the steps off.
I realize that. But okay, so let's convert to logarithmic form and then see what happens. I have log, what? E, 3x equals 7. Okay, is there anything you can do with that? You can't divide 3 because this is like on lockdown right here. You can't do anything to that, right? Okay, what can I do? Okay, let's start with the base. The base is e, the exponent is equals. Now what could I do? You could, well, let's just, before we use a calculator, what could I do with this? Divide by 3? It is the same thing, but it looks prettier like this, Mo, right?
But you might know better what his answer is if you take the extra step in between.
Okay. So put that in a calculator. E to the 7th and divide by 3. What do you get? 365.544. Good. Write it down. All right, let's try one more, and then we'll go back. Okay. What do you guys think? There's a couple different ways to do this. First of all, what do we need to put on lockdown? Okay. You could. Let's convert it. Let's see what happens. Log base e to the x minus 1 is greater than? Okay. So how could I take this? Don't look at these steps because I'm not doing it the way the book did it. What do you know about this? Okay. How is that going to help you though? You don't have a log on this side. Right? Let's change it to exponential form. Exactly. So let's talk about what x is first. X minus 1. That's why you raise your hand. So x minus 1 is greater than what? E to the negative 2. Right? Add 1. X is greater than e to the negative 2 plus 1. Put in a calculator. You want me to show you the other way to do it?
No.
It's longer.
No.
Nope, you're good? Okay. Okay, we're not done. Okay, what was this? 1.1353. Okay, two things I have to think about with inequalities, right? Because inequalities, the answer is not just one solution, right? It's more than one. It's everything larger than 1.1353. So if I've got more than one solution, what do I need to check? In here, what can this not be? 0. So x minus 1 cannot be 0. Therefore, x cannot be what? 1. Okay. Is any solution in here going to be 1? X is going to be greater than 1.1353. So I can say that this is my final answer right there. Let's do another one. So make sure you have that copied down. We're going to do that right now. This is one of those instances, Evan, where you're going to have to do some other work. Okay, so copy this one down and then try this one on your own. One recording. Okay, so let's kind of pay attention to these steps now that I X'd out. You guys, I showed you one way to do it. Here's another way you can do it. Okay? Remember how we did take the log of both sides sometimes? I'm going to take e to both sides. First, let's change this to logarithmic form. So this would be log e to 3x plus 2, correct? Okay, everybody with me? All right. Now I'm going to do this. I'm going to take e to the log e 3x plus 2. And if I do it to this side, I got to do it to the other side too, right? E to the 5th. See how I did that? Property of equality. You did it the easier way. But if you had natural logs on both sides, this is what you would have to do. So does everybody see what I just did? Remember this? 5 to the log 5x. What is that? X. So what is e to the log e 3x plus 2? 3x plus 2 is less than, what is e to the 5th? Well, we'll do e to the 5th. Right? Doesn't that just cancel this out? Now you could just subtract 2 and I would get 3x is less than e to the 5th minus 2. Is that sort of looking like what you had now?
That looks like what I do.
Now divide both sides by 3. And what do you get? X is less than e to the 5th minus 2 divided by 3. So I got 48.80. Okay, let's talk about our limitation. Shh, guys, it doesn't matter unless we finish this. Hold on.
Sorry.
Oh, no, you're going to want this. Okay. What can X not be? No, do not pack up. 3x plus 2 cannot be equal to 0. Therefore, x cannot be equal to what? Negative 2. No. Hold. Sit down. I do too. It starts with finishing this. Okay. So, I'm going to draw myself a number line. X is less than 48. 48's here. Negative 2/3 is somewhere over here. So, if x is less than 48, where does that stop? Right there. So it's all of this, so it would be x is in between 48.80 and negative 2/3. We're done.